What is the observable universe, and what lies beyond it? The observable universe refers to the portion of the cosmos that we can detect and study using telescopes and other instruments. However, this observable range is limited because light, the primary source of astronomical information, travels at a finite speed. We can only observe objects whose light has had enough time to reach us. This means we are essentially looking into the past, and we cannot see beyond a certain distance. Currently, the diameter of the observable universe is estimated to be about 93 billion light-years, a figure that might seem puzzling given the universe's age of approximately 13.8 billion years. The reason for this discrepancy lies in the expansion of the universe. As space stretches, the distance between celestial objects increases, causing light from those distant sources to take even longer to arrive. Despite the enormous scale of what we can observe, there is still so much we do not understand. Fortunately, with powerful tools like NASA's James Webb Space Telescope (JWST) and other advanced instruments, scientists are uncovering new details about the structure, composition, and history of the cosmos. Recently, the JWST has captured never-before-seen structures in the farthest reaches of the observable universe. These discoveries give us a glimpse into the early universe and shed light on how galaxies formed shortly after the Big Bang. The telescope's ability to detect infrared light, which is stretched due to cosmic expansion, allows it to peer deeper into space and further back in time than any previous instrument. As exciting as the observable universe is, one question remains: what lies beyond it? To reach regions outside the observable universe, humanity would need to develop revolutionary methods of space travel, possibly involving space-time manipulation, such as distortion drives or wormholes. While these ideas are still purely theoretical and face skepticism, mainly due to their contradiction with the known laws of physics, they remain a topic of serious scientific debate. Even if faster-than-light travel were theoretically possible, it would require technological advancements far beyond our current capabilities. According to the theory of cosmic inflation, the actual universe could be at least 10 superscript 2 superscript 3 times larger than what we can observe, a number so vast that it's beyond human comprehension. Since we cannot measure or directly see beyond the observable limits, we rely on theoretical models and observations from deep space to infer what might exist in the unobservable universe. NASA, along with international space agencies and research institutions, has been pivotal in enhancing our understanding of the cosmos. Even before the JWST became operational, Hubble Space Telescope had already captured extraordinary images of deep space, including the famous ultra-deep field. But with JWST's debut, astronomers have now observed the most distant galaxy ever recorded, offering a glimpse of galaxies as they appeared just a few 100 million years after the Big Bang. The expansion of space causes light to stretch to redder wavelengths, a phenomenon known as redshift, making it possible for JWST to detect ancient galaxies in the infrared spectrum. These observations are helping scientists determine how fast stars were forming in the early universe and have revealed a significant population of ancient galaxies. These discoveries are not just scientifically valuable, they're deeply inspiring. For centuries, humanity has wondered whether we are alone in this vast universe. The presence of millions of galaxies within the observable universe suggests that the unobservable portion might contain billions more, possibly harboring a condition for life. If you're as fascinated by space exploration as we are, don't forget to subscribe to our channel, like this video, and turn on the notification bell to stay updated on the latest discoveries from the universe and beyond. The idea is nothing short of astonishing. It stirs awe and wonder about the sheer immensity of the cosmos. Could there be other forms of life somewhere out there? The possibility of extraterrestrial beings has never felt more plausible. With advances in space exploration, particularly the discovery of numerous exoplanets, planets beyond our solar system, this idea gains even more traction. Techniques like the transit method and radial velocity method have allowed scientists to identify these distant worlds, some of which share characteristics with Earth and may be capable of supporting life. One such discovery involves the exoplanet WASP 96b, observed by the James Webb Space Telescope. This planet lies outside our solar system, and its light spectrum has revealed the presence of water molecules, a groundbreaking find. Even more surprising, Traces of haze and clouds were also detected, features previously thought unlikely on a potentially habitable planet. Given the increasing number of exoplanets and advancements in astronomical observation, it's becoming harder to dismiss the possibility that alien life exists somewhere in the universe. While we haven't yet found definitive proof, the growing body of evidence makes the idea of extraterrestrial life increasingly compelling. But the questions don't stop there. What about the multiverse? The concept of a multiverse, also known as the many-worlds interpretation, is a fascinating and speculative idea in physics and philosophy. It proposes the existence of multiple, parallel universes beyond our own. In quantum physics, some interpretations suggest that every observation splits reality into multiple outcomes, each existing in its own universe. Although this idea is still highly theoretical and lacks concrete evidence, it captivates both scientists and philosophers. Like Schrodinger's cat or the question of what lies in the darkness between stars, the multiverse pushes us to expand the boundaries of what we consider possible. And then there's the mystery of dark flow. First proposed in 2008, dark flow describes the unusual movement of some galaxy clusters that appear to be traveling faster than expected, possibly pulled by some unknown force outside the observable universe. One hypothesis is that this motion could be influenced by a massive structure, dark matter, or even dark energy. However, the concept remains controversial. Some studies suggest it could be a real phenomenon, while others argue the observed motion might be due to measurement errors or other unknown factors. As of now, we can't confirm whether dark flow truly exists. We need more data and research to unravel its secrets. So what do you think? Is alien life out there? Could the multiverse be real? Does dark flow hint at something beyond the limits of what we can see? Let us know your thoughts in the comments below. And if you're fascinated by the mysteries of the universe, don't forget to like, subscribe, and stay tuned for our next video. Remember, 95% of our universe is still a mystery, with dark matter making up around 27% and dark energy about 68%. The quest to understand what lies beyond has only just begun. The remaining 68%, mysteries that still elude us. Despite their profound impact on the structure and evolution of the cosmos, we have yet to directly detect either of the two elusive components, dark matter and dark energy, that make up roughly 68% of the universe. However, the future of our cosmic understanding is filled with promise. Each new discovery leads to more questions, opening exciting avenues for further exploration. The universe, in all its vastness and complexity, continues to reflect the boundless potential of scientific inquiry. Whether it's deciphering the secrets of dark matter, searching for extraterrestrial life, or probing the very fabric of space-time, our pursuit of knowledge will continue to shape human history for generations. Will we ever travel beyond the observable universe? As we look to the future of space exploration, one natural question emerges. Could humanity ever journey beyond the observable universe? Although this idea currently lies far beyond the reach of our technology, it's not entirely confined to science fiction. It reflects our innate desire to explore the unknown. At present, even reaching the nearest star system, Alpha Centauri, would take tens of thousands of years using our fastest spacecraft. Escaping not just our galaxy, but the bounds of the observable universe, would require unprecedented advancements in propulsion, energy production, and potentially a complete rethinking of the laws of physics as we know them. One theoretical solution comes from the concept of warp drives, proposed mechanisms that could bend space-time to achieve faster-than-light travel. Based on Einstein's general relativity, concepts like the Alcubierre drive propose creating a warp bubble that contracts space in front of the ship and expands behind, allowing the vessel to move faster than light relative to the outside universe. Still, the required energy and unknown side effects pose major scientific hurdles. Another idea from theoretical physics involves wormholes, hypothetical tunnels through space-time that could link distant parts of the universe, or even different universes. While general relativity allows for the existence of such phenomena, stabilizing a wormhole long enough for human travel remains purely speculative. Yet, whether by these exotic means or through future breakthroughs we can't yet imagine, it's possible that our descendants could one day journey far beyond the boundaries of today's known universe. The growing role of artificial intelligence in space exploration. Artificial intelligence, AI, is becoming an indispensable part of our mission to understand the cosmos. AI systems are now routinely used to analyze massive datasets from telescopes, guide interplanetary spacecraft, and identify exoplanets by detecting subtle patterns in light curves. NASA's Kepler and TESS missions, for instance, have leveraged machine learning algorithms to sift through enormous amounts of data, spotting possible planets orbiting distant stars. AI is also used to simulate galaxy formation, map the distribution of dark matter, and forecast cosmic phenomena. As next-generation telescopes and observatories come online, the volume of data they generate will grow exponentially. Without AI, parsing and interpreting this deluge of information would be nearly impossible. Looking ahead, AI could enable autonomous spacecraft to explore the outer reaches of our solar system and eventually interstellar space, making real-time decisions without relying on input from Earth. As our tools become more intelligent and adaptive, AI will be key to unlocking the universe's deepest secrets.